Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held in the month of March 2025. It is a rescheduled examination meant for Assam state. In this video, we discuss the solution of a problem from the section Real Analysis, and it is related to the sequences and their uniform convergence. This question is placed in part C, which is a multiple select question. There may be more than one answer and it carries 4.75 marks. The question ID is 706545. Further, this question is suitable for all these examinations. Right. The given question is, consider the following functions on the closed and bounded interval 0 to 1, that is the closed and bounded unit interval. G of x is a sine of pi x. H of x is cos of pi in brackets multiplied by x minus 1. Which of the following statements are true? We are given four options. Option 1. The sequence x power n multiplied by g of x converges uniformly on the unit interval. Option 2. The sequence x power n g of x does not converge uniformly on the interval. Option 3. The sequence x power n h of x converges uniformly on the unit interval. Option 4. The sequence x power n h of x does not converge uniformly on the unit interval 0 to 1. Let's now discuss the solution of the problem in detail. We are given two functions. G of x is equal to sine of pi x and h of x cos of pi multiplied by in brackets x minus 1 for all x belongs to the unit interval 0 to 1. Now you see h of x, it is equal to cos of pi multiplied by in brackets x minus 1 is cos of multiply pi x minus pi. Then it is cos of minus 1 times pi minus pi x, and that is cos of pi minus pi x. And cos of pi minus theta is minus cos theta, that is minus cos of pi x. And note that both these functions gx and hx are continuous. They are continuous on the unit closed and bounded interval 0 to 1. Agreed. We continue the discussion in the next slide. Right. We take options 1 and 2. Option 1 says the sequence x power n g of x converges uniformly on the unit interval. Option 2 says does not converge. Right. To discuss the uniform convergence, first of all, let us see, is it pointwise convergent? Pointwise convergence of the sequence x power n g of x. We have x power n g of x is equal to x power n g of x is sine pi x. Agreed. Now for x belongs to the interval 0 to 1, closed at 0 end, and open at one end. That means it is 0 less than or equal to x less than 1. For that, limit n tends to infinity x to the power of n into g of x is limit n tends to infinity of x power n into sine pi x. And this will be 0. Why? Because limit n tends to infinity of x to the power of n will be 0 because x belongs to the interval 0 to 1 where it is closed at 0 end and open at 1 end. That means 0 less than or equal to x less than 1, limit n tends to infinity of x to the power of n is 0. It's a well-known fact. And sine pi x is bounded. For that reason, the product, when you take the limit, it will be 0. Now, for x is equal to 1, what happens at x is equal to 1? We have limit n tends to infinity of x to the power of n g of x. It is limit n tends to infinity of x is 1 power n into sine pi. Because sine pi x is 1. Sine pi is 0. Sine pi is 0. So it is 0. It is 0. In any case, limit n tends to infinity of x to the power of n g of x is tending to 0. Thus, the sequence x power n g of x is pointwise convergent to f on the unit interval where f of x is 0 for all x belongs to the unit interval 0 to 1. Right. Now, we have seen it is pointwise convergent to f on 0 to 1 where f of x is 0 for all x belongs to 0 to 1. Now, we discuss its uniform convergence. Right. To discuss the uniform convergence, we take Mn is the supremum of x belongs to the unit interval supremum is taken on modulus of x power n g of x minus f of x. F of x is anyway 0. So, supremum of x belongs to 0 to 1 modulus of x power n into sine pi x. And remember x power n sine pi x is continuous in the interval 0 to 1. So, we remember here a well-known theorem called maximum minimum theorem. It's also called extreme value theorem. Let I be a closed and bounded interval and the closed and bounded interval like a comma b. Let f be a real valued continuous function defined on I. Then f has an absolute maximum and an absolute minimum on I. That means this absolute will have a maximum or minimum somewhere in the interval, closed and bounded interval 0 to 1. So, note that mod of x to the power of n sine pi x is continuous. X power n sine pi x is continuous and mod also is continuous in 0 to 1 by maximum minimum theorem from real analysis, and it's also called extreme value theorem. This modulus of x power n sine pi x has maximum in the closed and bounded interval 0 to 1. Yes. So, Mn will be supremum of this modulus is equal to modulus c power n sine pi c for some c belongs to the closed and bounded interval 0 to 1. That much I can say. Now, what I see is if now this x power n sine pi x will vanish when x is 0. X power n sine pi x also vanishes when x is equal to 1 because of sine pi. So, here x power n sine pi x vanishes at the end points of the interval, namely 0 and 1. And what happens for x belongs to the open interval 0 to 1? Then x power n sine pi x is not 0. Yes, sine pi x is also not 0. Is not 0. So, therefore, the maximum must vanish not at the end points, somewhere in the interior point of the open set 0 to 1. Therefore, supremum is attained at some point c belongs to the open interval 0 to 1. Thus, Mn is equal to c power n modulus of sin pi c. At some point c belongs to the open interval 0 to 1. That is 0 less than c less than 1. Then when you take as n tends to infinity, c power n tends to 0 and sin pi c is fixed. Therefore, mn tends to 0 as n tends to infinity. So mn tends to 0 as n tends to infinity since c belongs to 0 to 1. Yes. Thus, it is well known. If this tends to 0 as n tends to infinity, then the sequence is uniformly convergent. Therefore, this implies the sequence x power n g of x converges uniformly on the unit closed and bounded interval 0, 1. Yes. So the option 1 is true and option 2 is not true. Agreed. We move on to the next slide for the discussion of the options 3 and 4. Right, we have already seen h of x is minus cos pi x. X belongs to the unit closed interval 0 to 1. Let's call on options 3 and 4. The sequence x power n h of x converges uniformly on 0 to 1. Option 4 says does not converge. Right. So as in the previous case, why not we talk about its pointwise convergence. Right. So we have x power n h of x is x power n. H of x is minus cos pi x, therefore minus x power n cos pi x. Clearly, x power n h of x is continuous. Because x power n is continuous, h of x is also continuous on 0 to 1. This is required for us. Now, for x belongs to the interval 0 to 1, where this interval is closed at 0n and open at 1n, that means 0 less than or equal to x less than 1, then we have limit n tends to infinity of x to the power of n h of x is minus limit n tends to infinity of cos x to the power of n cos pi of x. And x to the power of n as n tends to infinity will tend to 0 because x is 0 less than or equal to x less than 1 and cos pi x is a bounded sequence, bounded one. It will be 0 since limit n tends to infinity of x to the power of n is 0 as x belongs to the semi-closed interval 0 to 1 closed at 0n and cos pi x is bounded. For x is equal to 1, we have limit n tends to infinity of x to the power of n h of x is minus limit n tends to infinity of 1 power n cos pi. And cos pi is minus 1 and 1 power n is 1. There is no need of taking limit and it is minus 1 into minus, that is plus 1. So what's happening? It is converging pointwise to f of x, where what is f of x? Where f of x is 0 for when 0 less than or equal to x less than 1 and is 1 when x is equal to 1. Look at f of x carefully. It is continuous everywhere except at x is equal to 1, where it has a jump discontinuity. Thus f is discontinuous on the closed and bounded interval 0 to 1. Clearly, f is discontinuous on 0 to 1. Now, here you have to recall this result. And when you have the sequence of continuous functions, and if they are uniformly convergent on a subset E of R, then the limit function, that is the pointwise limit function, f, must also be continuous on E. But whereas here it is not. Therefore, the sequence is not uniformly convergent. So the sequence x power n h of x is not uniformly convergent on 0 to 1, closed interval 0 to 1, since the pointwise limit function f is discontinuous on 0 to 1 and the the terms of the sequence, each one is continuous on 0 to 1. Using this result, this is not sequence x power n h of x does not converge uniformly on the closed and bounded interval 0 to 1. So thus option 4 is true, does not converge is option 4 is true, and option 3 is not true. And we already have option 1 is true. So summarizing all the options, the answer to this question is options 1 and 4. That is the detailed discussion of the solution of this problem from section real analysis related to uniform convergence of sequences. And in my opinion, it is a regular routine question. Therefore, it is definitely, I say, a very easy question. Right. Summarize all your knowledge from uniform convergence, definitions, and the MN test for sequences, uniform convergence sequences, and this result, and so on and so forth. All the results, you enumerate all of them, jot down at one point, at some point of time, and that will be helpful for you for the ensuing examination. Right. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like all my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I'm sure. So I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best, all the best, all the best. Thank you.